Hello again. In this video I'm going to show you how to use the PHD2 Static Polar Alignment tool, or SPA. Specifically, it covers the use of SPA to polar align your mount accurately using the automated slewing mode. To do this, you need to be able to see the region around the celestial pole, and your mount should be fairly well polar aligned already using the Polar Drift Alignment tool. And you should have performed a calibration with your camera. You'll need a go-to mount that is supported by PHD2, and you'll need a camera that is supported in PHD2 and has a reasonable field of view. A guide camera through an off-axis guider is usually not suitable, but an imaging camera could be used if PHD2 supports it. All star alignment or sync points should be cleared from the mount. To start out, we launch PHD2 and connect it to a defined profile. In this example, we're connecting both the camera and the mount. Having the correct focal length is important for calculating and reporting the alignment error accurately in arc minutes, so check that it is entered correctly. You can then start the camera looping with an exposure of about 1 second. This will make it easier to make the mount adjustments later. You might need to adjust the camera gain and or binning to get a good frame rate. Adjust the screen brightness so you can see the stars clearly. You'll need that when it comes to making adjustments later. Make sure the mount is unparked and tracking at sidereal rate, and make sure the scope is pointing near the celestial pole, which means a declination of close to 90 degrees. Start the Static Polar Alignment tool from the Tools menu. The SPA window pops up, and if you've got a computer-connected mount, the hemisphere is automatically selected. Compare the star map to the main display. The stars should match up. If the star map is 180 degrees rotated from the main display, then tick the Flip Camera checkbox. If the star map is offset from the main display, you can double-click any point on the star map to center it. In that way, you can pan the star map. It will always show a red line as a wayfinder back to the pole. You can alter the hour angle to rotate the star map so it matches the main display better. If you are pointing at a part of the sky away from the pole, you can click the greater than button beside a reference star to center it. Select a reference star on the main display. Identify the same star on the star map and select it from the drop-down list of reference stars. This can be changed at any time. Click the Rotate button. It changes to a Stop button and the mount will start to slew automatically to the west. If it appears to be out of control, click the Stop button. The mount moves slowly at first in small steps that should keep the guide star inside of the search box. If the slew causes the guide star to be lost, it's possible that the star is too far away from the pole, or that your polar alignment is a long way out. It could also be the case that the mount is simply slewing too fast. Alignment or sync points can also cause the mount to slew in an unexpected way. If this situation occurs, check and adjust your polar alignment with the Polar Drift Alignment tool, and also consider using the manual slew mode. After the initial small slewing steps, the mount will start to slew more quickly. It will typically rotate around 15 degrees before recording the final guide star position. The main display will show an overlay of the possible reference stars and their orbits around the pole. A magenta orbit shows the arc traced by the guide star. A green orbit shows the arc that should be traced by the reference star. It will hopefully be close to the magenta orbit. A green hole shows where the reference star ought to be, and it will hopefully be near the guide star. Yellow orbits correspond to the other possible reference stars, and yellow holes show where those stars ought to be. A grey line shows the overall adjustment from the selected reference star to its target position. A red line shows the required altitude adjustment, and a blue line shows the required azimuth adjustment. If the overlay is getting in the way, you can turn off the orbits by unticking Show Orbits. If the display and star positions don't match up fairly well, check again to see if the star map needs to be flipped. For greatest accuracy, fine-tune the hour angle value so that all the visible reference stars have the same offset from their holes in both distance and direction. As you alter the hour angle, you will see the orbits rotate and the adjustment lines change. Now you can adjust your mount's azimuth and altitude to place the reference star into its green hole. You will get maximum accuracy by placing other stars into their yellow holes at the same time. A magnifier tool can be used to zoom into the display and place the stars accurately.